let's take a really quick look at fractions and mixed numbers. And when we start talking about fractions, we need to talk about common denominators, of course, because to add and subtract fractions, you must have a common denominator. And then to get common denominators, quite often we need to factor numbers into primes. So let's go over that quickly. If I could give you the number 60 as an example number 1 and tell you to factor it into primes, you could start off with a factor tree. We could say 60 factors into what two numbers? Any two factors. We can begin with any two. Let's start with 6 and 10. Neither 6 nor 10 is prime, so we're going to factor each of them again. 6 factors into what two numbers? Well, 2 times 3 is 6. Now, both 2 and 3 are prime. Remember what we mean by prime. It is a number that can be divided by nothing except itself and the number 1. That's when you know you have a prime number. So 2 and 3, 5, 7, 11, these are some at 13. These are some of your prime numbers. And of course, number 1 is always prime too. Now 10 factors into 2 times 5. And both 2 and 5 are prime numbers. I'm going to circle them once I have my primes. I want to just write 60 as a factor of those primes, so I'm going to say 60 is equal to 2 times 3 times 5. You notice I started from the lowest factors and worked my way up. Now, we would write it again in exponential notation. We would say 2 times 2 is really 2 squared, times 3 times 5 is another way to write that factorization. Let's take 56 and do the same thing. Well, I don't really know factors of 56, but I'm going to start with 2 because it's an even number, okay? And 2 is prime, and 2 times 28 gives me 56. Well, I don't have to do any more with 2, but 28 is also another even number. Let's factor it to 2 times 14. 2 is prime, but 14 we need to factor again. 2 times 7, and those are prime. So 56 is 2 times 2 times 2 times 7, or we could write that as exponential notation, 2 to the power of 3 times 7. Now, example 3 has a fraction that we need to reduce to lowest terms. How we do that is we divide each of the fractions, each part, the numerator and the denominator, by the greatest number that we can divide evenly into both of them. But if you look at 15 and 20, you probably see that we could divide them both by 5. We can always divide both the numerator and the denominator by the same thing because, look, what we're really doing is dividing by 5 over 5, which is just the number 1. So we've kept equivalency in our fractions. 15 divided by 5 is 3. 20 divided by 5 is 4. And when you're reducing numbers, always check and make sure you have reduced it as low as it will go. Sometimes you'll have to reduce it twice, but 3 over 4 is as low as this will go. Let's take 42 over 45. Now, and that's not readily apparent what we can divide both of those by. 2 won't go into both of them. But what about the number 3? The way you can tell if a number will evenly divide by 3 is to add the digits and see if the sum of the digits will divide by 3. In other words, for 42, I would say 4 plus 2 gives me 6. And 6 can divide by 3, so it checks. It's good. 42 will also divide by 3 evenly. 42 divided by 3, I can put it out here for you, is going to be 1, and it's going to be 4. It's going to be 14. So we can divide 42 by 3. It gives us 14. And I happen to know what 45 divided by 3 is. It's 15. And I look at that number 14 over 15, and I know that there's no common factors I can divide both of them by, so that is the lowest form. Number 5 is multiplying fractions. Now, when we multiply fractions, we don't have to have a common denominator. We simply multiply numerator times numerator, denominator times denominator, and then we would have to reduce. But there's a shortcut. Before you multiply, you can reduce any individual fraction, or you can cross-reduce any fraction. So I don't see 7/8 will not reduce, and 3/21, well, I can reduce 3 over 21. 3 will go into both of those. 3 will go into 3 one time, and 3 will go into 21 7 times. Now, I can cross-reduce 7 over 7. Any numerator with any denominator, right? So 7 will go into both of those once. It leaves the number 1. Now I'm going to multiply what's left in my numerators. 1 times 1 gives me 1. In my denominators, 8 times 1 will give me 8. And my answer is already in lowest form, 1 over 8. That's definitely shorter shorter process than multiplying 7 times 3 and getting 21, 8 times 21, and then having to reduce that huge fraction. Example 6 is division of fractions. The thing you need to remember about division is we don't ever divide fractions. We multiply by the reciprocal. So the first fraction stays the same. We change the process to multiplication, and we flip the second fraction. Now once I flipped, 9/10 becomes 10 over 9, and I can cross-reduce those two fractions. I can say 3 goes into both 3 and 9. 3 into 3 is 1, 3 into 9 is 3, and 5 will divide into 5 and 10. Now I'm multiplying by much smaller numbers now. 2 times 1 is 2, and 1 times 3 is 3, and that's my lowest form of that division problem. Example 7, adding and subtracting fractions is always harder than multiplying and dividing because we do have to have a common denominator. Example 7 has made it easy for us. The common denominator is 35. We will put that in the denominator, and we're going to write everything else, including the signs and the operations, in the numerator. In my numerator will be negative 16 plus 1. Now all I have to do is say negative 16 plus 1, well that gives me a negative 15 over 35, and I need to reduce that. Always have to reduce fractions. Both of them I can divide by the number 5. It will give me a negative 3/7. And when we have a negative in a fraction, we either put it out front or in the numerator. It just means the entire number, the whole fraction, is negative when there's only one negative. Let's take a look at example number 8. We're going to subtract fractions this time, but before we do, we're going to have to convert, because adding and subtraction, I have to have a common denominator. My denominators are 15 and 12, and it might not be so easy to see what a common denominator is, so I can use the process of finding an LCD. I can factor each of those numbers to primes. 15 factored to primes is 3 times 5. 12 factored to primes, I just know this one is 2 times 2 times 5. Those are the primes. It would be 4 times 5 and 4 factors to 2 times 2. Now, the numbers I'm going to use in my LCD are going to be 2s and 3s and 5s. And I will use the most of any one number that I find. So I have 2 2s in here. I'll have to use both of them. I have 1 3. I'll have to use it. And then I only have 1 5 in each. I don't have to use both 5s, but I just have to use one of these 5s. So when I multiply out these numbers, I find that my least common denominator is going to be 4 times 15, which I know is 60. 60 is my least common denominator. I need to translate both fractions to something over 60s. Everything else stays the same. These are my fractions. How do I get 15 to become 60? Well, I'll have to multiply that 15 times 4. So I multiply the numerator times 4. 4 times 4 gives me 16 over 60. That's how 4 over 15 becomes 16 over 60. For the 1/12, I know I have to multiply 12 times 5 to get 60, so I'll have to do the same thing to the numerator and multiply 1 times 5. Now I have 5 over 60. I have the common denominator of 60. Everything else in the numerator would be 16 minus 5. That gives me 11 over 60. I look to see if I can reduce it, and I can't, so that's my lowest form. Example 9 is division, but this time it's mixed numbers. Once again, mixed numbers. If I'm doing division, I've got to change my mixed numbers to improper fractions. The process for doing that is I take the whole number 8, multiply it times 5, and then I add 3. You can think of it as making a circle. First thing I'm going to do is multiplication, then I'm going to do addition. I'm going to say 8 times 5 is 40, plus 3 is 43, and I'm going to place that over the denominator that was already there, which is 5. Now remember, your denominators are not going to change when you're converting from mixed numbers to improper, or from improper back to mixed numbers. That denominator stays the same. Then I'm going to say division, and I say the same thing with 2 and 9/10. I say 2 times 10 plus 9, working around in a circle like this. So that would be 29/10. Well, I never divide fractions. I multiply by the reciprocal. The first fraction must stay the same. The second one, I'm going to flip it. It's going to be 10 over 29. And then I look to see, can I reduce? Because I really don't want to multiply these huge numbers. 5 will go into both 5 and 10. And I don't see anything else that's going to reduce for me. So I'm going to have to just multiply. 2 times 43 is going to give me 86. And 1 times 29 is 29. Now, we've got an improper fraction. We're going to change it back into a mixed number because our problem started with mixed numbers. So I'm going to say 86, which is the way we read fractions, are really like division problems. 86 divided by 29. How many times will 29 go into 86? Well, it looks like 2 times. 9 times 2, 18. Carry my 1. 2 times 2 is 4 plus 1, that's 58. When I subtract, I end up with 8, and I borrowed from the 8, so I have 7 minus 5, which is 2. I have 28. That's my fractional remainder, the numerator. The denominator always stays the same, and it's what I divided by, 29. The answer is 2 and 28 29ths, which does not reduce, so we leave it in that format. Example 10, we're going to be subtracting mixed numbers. Now, we don't really have to go all the way into changing mixed numbers to improper fractions when we do adding and subtracting. We can just write it a little differently. We can say 4 and 7/8 and put underneath it minus 2 3/16. What we're going to try to do, we're going to try and get away with subtracting the whole numbers and then subtracting the fractions from the fractions, okay? Because that would make it so much easier for us. Look, I can't subtract 16ths from 8ths. I've got to change it to a common denominator. I'm going to change it to something over 16. Well, I had to multiply 8 times 2, so I'll multiply 7 times 2. It becomes 14/16. Now, I'm treating it like 2 separate problems, so I'm not going to worry about this 4 minus 2, because it's a whole number of 2, right? I'm just doing the fraction portion. What about my 3/16? Well, I'm going to subtract just 3/16. Now look, I've got this problem here. I've got 14/16 minus 3/16. Remember, down here in the denominator, I've got 16ths. In the numerator, 14 minus 3, which is 11. My answer here is pretty easy. I just have to put these two together, and I have an answer of 2 and 11/16. Let's sort of do the same thing when we're working at example number 11 and we're adding mixed numbers. Let's add 17 and 2/5 plus 30 and 2/3. I'm going to write them together. 17 and 2/5 plus 30 and 2/3. And bear with me, I've tried to keep this on one page, and so I'm running out of room down here. Now I can add just the whole number portion. That's pretty easy. 7 and 0, 3 and 1. Okay, I got 47 there. Now, adding fifths and thirds, I have to have a common denominator. My common denominator is going to be 15. So let's translate these. I'm going to have 6/15 for my first fraction. And for my second one, I need it to be 15ths. What do I multiply both by? Fifths, 5 over 5. So that'll be 10/15ths, right? Now I'm adding. So I'm going to say, how many 15ths does that give me? 6 plus 10 is 16/15ths. Well, that's an improper fraction, isn't it? If I take and divide 16 divided by 15, I end up with 1. I subtract. I have 1/15th left over. I have to take this answer and add it to my 47. 47 and 1/15 is getting added to it, isn't it? I end up with 48, and 1/15 is my answer. Okay, example number 2. I'm also crowded on this one, so sorry guys, you're just going to bear with me, okay? The problem, 2 1/4 times 3 2/3. Once again, I'm multiplying. I need to get improper fractions when I'm multiplying instead of mixed numbers. So I'm going to say 2 times 4 will give me 8 plus 1, that's going to be 9/4. And I'll multiply that times 3, which is 9 plus 2 would be 11/3. And before I multiply fractions, I look see if I can reduce or cross-reduce. And I can cross-reduce the 3 and the 9. And then when I multiply, I have 33/4. which is improper fraction. I don't want to leave it that way. Since I started with a mixed number, I will end with a mixed number. I will say 33 divided by 4. 4 goes into 33 8 times. And it has 1 left over, which I put over the fraction, the denominator of 4, the answer 8 1/4.